Good day everyone. Today, we are going to tackle about atoms, their history, and their compositions. Let's start.
Atoms are these ridiculously small particles also known as the fundamental building blocks of chemistry. Matter, which is everything that occupies space and has mass, are made of collection of different atoms. They are these tiny bits that makes up literally everything around us, from your own body, the air, our food, the house that you're living in, and even the screen that you're looking in right now. In fact, there are about 7 billion atoms that are present in your body alone, but they are so tiny that only the world's most powerful microscope can see it. In short, atoms makes up all the matters in the world. Aren't you curious on who are the brilliant minds that discovers atom? In order to know it, let us go back to 400 BC and let me introduce you to Democritus, which is known as the man who proposed the idea of atom in his day. He states that if you were to chop up a piece of matter, an apple for example, you could just keep on chopping it forever as there were no end to smallness. Although this reason are not fully agreed on by historians, making Democritus doubt his concept, resulting in him insisting that at some point, you can reach particles so small they become indestructible and cannot be divided any further. He called it atomos or atoms, which means uncuttable. For some reason, many people did not accept this concept because of the lack of evidence and just simply rejected it. Now, let's jump in 1700 AD, where the first French husband and wife Marie-Anne Pauls and Antoine Lavoisier found that certain pure substances could be broken down even further through chemical reactions. For example is the boiling of water that produces steam, but it is still water, but it can also be split into two pure gases which are hydrogen and oxygen. They tried to separate these two gases, but it can't be done, making them conclude that these must be elements. With this, scientists began to search different elements until they have discovered all the 118 listed in our periodic table. Atoms then have remained forgotten until 1808 when a teacher named John Dalton shows that common substances always broke down into same elements in the same proportions. He concluded that the various compounds were combinations of atoms of different elements with each of particular size and mass that cannot be created nor destroyed. Almost a century later is the physicist J.J. Thomson's discovery of electron. Using the chocolate chip cookie model of atom, he shows that atoms are uniformly packed spheres of positive matters filled with negatively charged electrons that resulted in him winning a Nobel Prize. Another one of his brilliant student, Ernest Rutherford, that is now known as the father of the nuclear age, decided to investigate atoms more closely by shooting small particles at a sheet of gold foil, making him conclude that atoms consisted largely of empty space with just a few electrons, while most of the mass was concentrated in the center, which he called the nucleus. The alpha particles pass through the gaps but bounce back when it hits the dense nucleus. After all of this discovery, the atomic theory is still not complete just yet. Not until 1931 when another student of Thomson named Niels Bohr expanded Rutherford's nuclear model. He stated that electrons orbits the nucleus at fixed energies and distance. Bohr's planetary models remained on spotlight but then later encountered some complications. Although an atom is already small, it still consists of three smaller subatomic particles: protons, neutrons, and electrons. Protons that are positively charged and neutrons that has no charge bind together and form the positively charged atom core or the nucleus that is surrounded by electrons which orbits around it in rings. Protons and neutrons have the same mass. The electrons, however, are so small they weigh almost nothing compared to protons and neutrons. In fact, they are around 2,000 times lighter, resulting on the mass of the electron to be concentrated to its nucleus. With all of this, we can say that the protons and neutrons are what gives the atom its weight. Take the silver atoms for example. This atom consists of 47 protons with 60 neutrons. This is much heavier in comparison to a nitrogen atom that consists of 7 protons and 7 neutrons. And that's it for this video. I hope that you've learned something. Thank you.